Hello everyone. So the daily question for today is find the power of case size subarrays. You are given an array of integers nums of length n and a positive integer k. The power of an array is defined as its maximum element if all of its elements are consecutive and sorted in ascending order and minus one otherwise. Okay. We need to find the power of all subarrays of nums of size k, where a subarray is defined as a subarray is a contiguous non-empty sequence of elements within an array. Okay, so we need to return an integer array results of this size, where results as at I is the power of the array from nums at I to I plus k minus 1. Okay, so let us consider this test case. Let me write it here. So the test case is like 1, 2, 3, 4, 3, 2, and 5. Okay. So let us consider this test case where we are given this array and we need to compute the power of each subarray of size k equal to 3. So the first subarray here is this 1, 2, 3. So the first condition for this subarray to be valid is that the elements must be sorted and consecutive. So the first element is 1, then it is 2, then it is 3. So they are consecutive elements because each of the adjacent elements differ by a difference of 1, and they are also sorted in ascending order as we can see. And the next subarray is this, which is also valid. This one is not a valid subarray because we are having the first element is 3, then the second element is 4, and the third element, which should have been a 5, is a 3. So now how do we compute the power for a valid subarray is by taking the maximum element in that subarray. So there are several approaches that we can try here. And looking at the constraints of the problem, where n is up to 500, which tells us that we can use an approach of up to n square, and even n cube may work. So let us try with the first brute force approach that comes to the mind is to use two pointers to indicate the starting and ending of each subarray that we are going to consider. And since the size of the subarray is predefined, we can do this via choosing the starting position of a subarray, and since the size is predefined, we can use the ending position as starting position plus the size of the subarray minus 1, and that would give us the ending of that subarray. And then what we need to do is we need to find the maximum element in that subarray, and we also need to check if the array is valid or not. So let us try this out. So I'm going to take an integer variable to indicate the length of the subarray. So I'm going to use the pointer I to indicate the starting of each subarray that I'm going to consider. Now since we are given a size of the subarray that we need to consider, we cannot choose all the elements at the starting point of our subarray. So let us consider this test case, and where k is equal to 3. So if I'm standing at the last element, and if I want to make that as the starting of a subarray, we can see that there are just not enough elements to make the subarray size equal to 3, because there is only just one element. Similarly, we cannot be at the last second position because then also we are going to only have a maximum of 2 elements. So we need to take that into account. So if we see that k is equal to 3 and the length of this subarray is 437, so we can do 7 minus 3, which will give us 4. And if we go index wise, this will be 0th index, first index, second index, third index, and fourth index, which is also all the valid positions of the starting element of a subarray. So what we can do is we can run the loop from 0 to n minus k. Why n minus k? Because we need to take into account the size of the subarrays that we are going to consider. And we must be having sufficient elements for that to happen. So having taken that into account, now what we need to do is select the key elements starting from I. So what do I mean by that is if I is equal to 0 and we are standing here, I need to select k elements. So that would be 1, 2, and 3. These three elements. And I also need to make sure while selecting these elements that they must be consecutive and sorted. So let us do that. I'm going to use another loop to select those elements, which will be for int j equal to I, because I is the starting point, and I need to select k elements, which I can do by running a loop from I to I plus k. How is that going to happen? And here will be j plus plus. So yeah, and how is that going to happen? Let's say I was standing at 2, which is the index 1. So I need to consider 1, 2, and 3. I need to go up to the third index. So if I see where this loop is going, it will go from j equal to 1 to j equal to 2 to j is less than I plus k, where I is 1 and k is 3, that is 4. So it will go from less than 4, that is up to 3, which will be 0, 1, 2. Oh, I'm sorry, which is 1, 2, 3, which is the subarray that we are considering here. So after having this loop here, so what I'm going to do now is to check whether these, so what I'm going to do now is to check whether these elements are according to this condition or not. So in order to do that, I'm going to keep here a flag variable int f is equal to 0, which is going to indicate whether the subarray that we are considering had any possible violations of this rule or not. What do I mean by that is, if a subarray is valid, the value of f will remain 0 even after the complete iteration of this loop. But if there was even just a single violation of the rule, we will set the value of f equal to 1. And later we can use the fact that whether the value of f is 0 or not to decide whether the subarray is valid or not. So we can do here, if each subarray must be sorted and consecutive. So what we can do is we can say that current element must be equal to previous element plus 1. So when we are standing at the starting of this subarray, there is no previous element for this subarray. So we need to take that into account. So we will say if j is greater than I, that is we are not standing at the starting of the subarray, and the current element, that is numsat j, is not equal to numsat j minus 1 plus 1. So what this means is that we are not standing at the starting of this subarray and we have found an element which is not equal to its previous element plus 1, which, if said in other words, is a violation of the rule that was mentioned above. So I can just set my flag variable to 1 and I can say violation of the rule was found. And I can also break out of here because I need not check any other element, since this violation alone makes this subarray an invalid subarray. So now here I will check if f is equal to 0. Okay. So here I will check whether f is 0 or not. So if f is 0, that means that the array that we are considering is valid. Now we need to find the power of this subarray, which is the maximum element. Now, one way of finding this power would be to again loop through all the elements and find the maximum element. But if we go by the definition of this subarray that we are considering, it says that the elements are consecutive and sorted in ascending order. And we have already checked whether this condition is fulfilled or not. So if f is equal to 0, we know that this prior condition is already fulfilled. And if this condition is true, we can always say that the last element of this current subarray is the maximum element of this subarray. So we can find the maximum element without having to run through the loop again. So what I will do is, now I need to store this answer and I will create an answer array for the same. Integer array answer is equal to new integer array of length n. Now yeah, the length is also given here. So I'm just going to use this because we are not going to have a new answer array of length n minus k plus 1 as mentioned here, just because of the same fact, the fact that we used for running the outer loop. Now what I can say is answer at I will be the last element of the current subarray, which is at numsat I plus k minus 1. Now why I have used I plus k minus 1 is because, just if you look here, we were running the loop from j running from I to I plus k. More precisely from I to I plus k minus 1, because we will not ever choose an element of I plus k. So if we are running the loop up to I plus k minus 1, so hence the last element of this subarray will be I plus k minus 1. So we have chosen that element, and that is the answer for this index. Now for any index that is not valid, the answer is minus 1. So I can just use an else here to set answer at I to a minus 1. And I can just return the answer error from here. So I can just return the answer error from here. Now if I run this, I'm getting that the answer is running well and good. I can also submit this, and we can see that it passes all the test cases. But this is an n square approach, and we can do better than that. So let me just refresh this editor again. Okay, now here I am. So if we look into this, we have to consider all the subarrays of size k. That means we are given a fixed size, and we have to consider all the subarrays. So this is a perfect candidate for a sliding window problem, where we consider a window of a given size and we slide it across the array one by one. So now what do I mean by that? So let me try to explain it a bit. Let me just take this test case here. So now, if I'm given this array and I have to consider a window of size 3 as mentioned here, so what I can do is I can initially consider a window. Okay, this will be the very first subarray that I would consider. Now, I'm not saying that we are solving the problem yet. I'm just trying to explain how the sliding window approach works. So if we have considered this subarray and we know that the size will remain fixed when we are sliding this subarray, by sliding I mean that we are going to move this window one by one. Now how can we move this window is we will discard the first element of the window and take into account the element coming next to the last element of the window. So if I do that, what I have now is this subarray. And in this, we did not have to actually take the entire subarray from the very beginning. We just removed one element and added one extra element, which is a constant time operation. I will repeat again. We will consider an initial window of the given size, and then when we are trying to slide it, we will just discard the first element of the current window and take into account the element that will come next to the last element of the current window, and that will give us the new window. So that is how we will slide this window. Now, how can we check this condition that whether it's maximum, whether the elements are consecutive and sorted or not? So what I can do is when I am building this window, I can check whether the window that I am building is holding true to this condition or not. Now, what do I mean by that? Since these first two subarrays are valid, I'm going to just skip to a case where we will find a violation. So if the next subarray would be 3, 4, and 3. Now when? So now this would be the next window that we would have. So when I'm building this window, I can see that the new element that I have added to my previously valid window, since 2, 3, 4 was a valid window, and for this window to remain valid, the next element that I am adding must be equal to the last element present in the window plus 1. But I can see that this element that I have added, 3, it is not following that condition. So this tells me that this array is not valid. So if I go for the next subarray here, which would be 4, 3, 2, I can see that this subarray is also not following the condition, and there are two violations. First one would be this, and the second one would be this. And actually, I can say one more thing, that is that whenever I find a violation, I am pretty sure that any subarray starting with this element or this element will always give an invalid subarray, because the violation of this type will always remain in that, which is also true for this subarray. This violation is here and this violation is here also. So whenever I find a violation, it is a waste of time to check this subarray again, because we are pretty sure that this violation will exist whether any future violation comes or not. the current violation that I had will always exist in that subarray as well. So we can always skip checking this window. How can we do that? Whenever I find a violation, I will discard all the elements that I have had before this violating element. What do I mean? I will repeat. Whenever I have a violation, I will discard all the elements that I have had in my window prior to this element. That is, since I found a violation here, I will quickly discard all the elements that I have had and my window reduces to say this. That is the last element only. And I've removed all the elements. Since I know that any array subarray starting with these elements will always remain invalid. And then I can again build that window again, which would be like 3, 2. And since when building that window again, I will again find a violation just in the next element that I will add. And again I will do the same. I will discard all the elements that I have had in my window prior to the current element. Now okay. Obviously this was the last window that we consider, and that's how we can build a window and check whether the window is valid or not. And once the window we have found is valid, we always just consider the last element of that window, which would be the maximum element as discussed in the previous approach. So how can we implement this? Now there are many ways of doing this. I'm just going to show one of those ways. So let me use an integer variable to indicate the size of this subarray, I mean array. And this sliding window approach can be implemented by using two variables to point the start and end of the current window. So I'm going to use beginning is equal to 0 and end is equal to 0. So now the BEG, that is beginning, will point to the starting of the current window and the end will point to the end of the current window. Now, as I said, I would initially build a window. So now you could also build this window prior to this method, but I'm going to do it within this method to avoid the redundancy of code. And it might also be helpful to do this here only because we are further going to be deleting elements, and not only one but many elements as I discussed in the test case. So let us see how this goes. And the ending of a window can be up to this element. How? Because even though the starting can be only up to here, but the ending element for this window would be this. So we know for sure that the ending of an element can go up to the last element. Ending of a subarray can go up to the last element. So with this, I'm gonna make this loop like that. So now why have I kept my beginning at 0 and incremented the end every time at every iteration of the loop? Is because the end pointer is pointing to the end of the current subarray. And when I'm wanting to add a new element, I must go beyond the last element of the current subarray. And since we are sliding a window every time, one by one, we need to keep incrementing the ending variable. Now, yes, the beginning will also have to be incremented, but let us consider this test case. So if I'm here, that is a 0, 0 element, and I've taken this element into my window, do I need to increment my beginning variable? And in order to answer that question, we must look at what is the size of the window that I'm building. It is 3. So have we exceeded that size? Have we taken into account more elements than allowed by the given size? No, we have only taken one element and we have to take a minimum of 3 elements. Not only minimum, we have to take exactly 3 elements. So we are at a deficit of elements. So we have to take into account exactly k elements. And how many elements have we taken? Only one. So we must not increment our beginning variable yet. If and in the next iteration my end will increment and we will take into account this window and this element into the current window. Is the window exceeding the number of elements? No. Again we will take an element. Now this window that I have currently, when end would reach the index of 2, would be equal to the size of the asked window. That would mean that when this condition happens, I will check all of these conditions here, whether these conditions are valid or not, and if yes, I will add the maximum element to as the answer to that window. And once I have done all that computation, now since adding another element to this window would lead to a violation in the size of the window, since we can only take a window of size exactly k, what I'm going to do is after doing all these computations, I will remove this element from the window. And how can I do that? I can do that by just incrementing the beginning variable. So now it will point to here. I have these two elements. And when I go into the next iteration, I will take the next element. And again, the window will be of size 3. And that is how we will slide this window. That is what we will do. Now, how will we check this condition consecutive and sorted? So as I mentioned earlier, we are going to check it just the way we did in the previous approach. That if now the starting element of a window is not to be considered for that check because it is a starting element and it does not have a element prior to it. So in order to make sure we are not checking the starting element, I can say end must be greater than beginning. What does this mean? This means that the ending of the window must not be equal to the starting of the window, because that is the case when we only have one element in the window, and that one element is the only element, so it will not have any prior element. So if that is the case and the element pointed by the end of this window that we have currently just now included is not equal to the element present prior to it plus 1, which is the condition for consecutive and sorted order. So if this is the case, that means we have found a violation. And what to do in case of violation? We will remove all the elements prior to this element. And how can we do that? By using the beginning pointer. We will move the beginning to the end of the current window. That means we have removed all the elements prior to the current element, and we are only considering the current element in our window. And once we are done with this, I'm going to remove these braces because they are not important. So now what I'm going to check is if the size of the current window is 3 or is equal to k or not. How can I do that? I can do that by using end minus beginning plus 1. That is, if this was a valid window, the positions of end would be 2 and the beginning would be 0. And if we subtract them, that is 2, and we add 1, we get 3. That is the size of this window. So if this size is equal to k, then what we need to do is we need to do all our computations that I mentioned earlier, and then we need to remove the first element of the window. So what we can say for sure that if we have come up to this point, then we are sure that this window is valid. Why? Because if we had found a violation, we would have already shrunk the window by using this statement. So we need not worry about entering this if statement and having a violation, because that will not happen because we have already taken care of that just prior to this. So now we know that the window is valid and we just need to fill the maximum element of this window and to our answer. So first let me create an answer array for that. So it will be answer is equal to new integer array of length n, and the position for this answer would be given by the starting of the subarray, and maximum element of this subarray is present at the end of the subarray. Once we are done with that, we will remove the first element from this window. And now for all the elements that we are unable to find an answer, those elements need to be -1. But I'm not going to do that here because we are moving our beginning and shifting positions. So we might skip some elements. So instead I am going to initially fill my array with -1s. So the answer array with -1. So that any element that remains unfilled in this iterations will be filled priorly. So now when we are done with this, we will return the answer array. So now we can run to see whether this approach works or not. And I will do a dry run for the same to make it more clear as to why this approach works. Okay, so we are getting some wrong answer here, and that is because we have not allocated the size of this array correctly, which is n minus k plus 1. So after we have done that, I can run this again, and it works. Now let us do a dry run to understand how this actually works. So let us consider this is only. So our beginning is at 0 and end is at 0. So we are at this element. I check this condition whether end is greater than beginning or not. It is not because both are at 0. So we come directly to this if statement. Is the size of the subarray equal to k? Where k is 3? No, it's 1. So we go ahead to the next iteration. We take into account the next element, that is 2. Is ending greater than beginning? Yes, because ending is at 1 and beginning is at 0. So we move onward to check this condition. So the nums at end, that is the current element, that is 2, is it not equal to its prior element plus 1? It is equal to that. So this is not a violation. So we skip this executing the statement and go to this if statement. Is the size of this subarray equal to k, which is equal to 3? No. So again we move ahead to the next iteration and we take into account the next element, that is 3. So is end greater than beginning? Yes. Is the element that we have currently included not equal to its prior element plus 1? It is equal to that. This is also not a violation for this. So we will again skip this statement and move onward to this statement. So we check whether the size of the current window is equal to k, which is equal to 3 or not. It is equal to that. So now what we will do is we will need to fill the answer array with the maximum element of this window. The maximum element, as previously discussed, would be at the end of this window. And where does this element need to be filled? At the position pointed by the beginning of the window. Once we have done that, we will again shrink the window. That is, we will discard this element. So now our window is reduced up to only this. In the next iteration, we will include this element as well. Our window will become something like this. We will check, is end greater than beginning? Yes, because beginning is at 1 and end is at 3. Now we will check whether the element that we have currently included is not equal to its prior element plus 1. It is equal to that. So this is also not a violation. We move forward, we check the size. Yes, the size is k, and we include the maximum element into the answer, and we again remove this 2, and the window becomes something like this. And then in the next iteration, we take on the next element, which is 3. So now our window is something like this. Now again we check, is end greater than beginning? Yes, because beginning is at 2 and end is at 4. So now, is the element that we have currently included not equal to its prior element plus 1? So is 3 that we have currently included not equal to 4, that is the prior element, plus 1, that is 5. So is 3 not equal to 5? It is not equal to 5. So we have found a violation. So once we have found a violation, as mentioned earlier, this subarray would also be invalid and this subarray would also be invalid, because both of these subarrays will contain this violation. So we need not waste our time checking this subarray. So we will directly discard all the elements except this element in the current window. So how do we do that? By setting beginning equal to end. So I've discarded all those elements. Now our window is only 3. We check, is the size of the window equal to k? No. We move forward. We take into account the next element, that is 2. So is end greater than beginning? Yes, because beginning is at 4 and end is at 5. So is the current element that we have just now included not equal to the prior element plus 1? It is not equal to that. So again we have found a violation. Again we will discard this element and only consider this element in a current window. And we will check whether the size of the window is equal to k or not. It is not equal to that. We move forward, we take into account the next element, that is 5. Is end greater than beginning? Yes. And is the current element we just now included not equal to the prior element plus 1? The current element is 5, the prior element is 2. 2 plus 1 would be 3. So 5 should have been 3, which is not. So it is also a violation. So again we remove all the elements and we only consider this window. Is the size of the window equal to k? No. Again we remove. Again we move forward and we find that we have traversed the entire array. And we are done. And then we return the answer. So let us submit this. And we can see it works just fine. So this is how we can solve this problem. And if you have any doubts regarding anything in this video, please mention them in the comment section. And if you like this video, make sure to smash that like button and hit the subscribe button as well. Thank you.